Thanks everyone for coming to the second OWASP Vancouver meetup for 2018. Our speaker tonight is Karim Lalji. Karim is an application security practitioner. His background is in application security, particularly in the banking and finance industries, and he currently works in a senior offensive security consulting role, conducting penetration testing and threat vulnerability assessments for a variety of clients. Karim was a software engineer in his past life, and securing applications has been a strong focus for a good portion of his career, and I'm glad to have him here tonight with us.
Thank you. All right, welcome everybody. You guys can hear me okay on the mic? Everything's good? Perfect. So we're going to talk a bit about managing vulnerabilities in a modern software environment. So when we talk about modern software environments, we're talking about things like agile methodologies and DevOps and continuous integration, continuous delivery. But before we get into that, a couple disclaimers. This is a bit of a high-level discussion. It's not as technical as in that I would normally go into. But we need to kind of get a broad view of the different components before we start trying to manage vulnerabilities. And there's going to be a few slides and a small section on software practices, because I can't make the assumption that everybody in this room has been a developer or works closely with developers. So we need to make sure everybody's at the same level before we kind of start going forward. So a bit of an introduction on me. I'm currently a managing consultant for TELUS, and I do mainly, as Farshad mentioned, pen testing and vulnerability assessment. Previous to that, I was focused in application security at Central One, and I actually see some of my colleagues sitting here, which was focused in digital banking. And I was also a software engineer and a sysadmin, so various different backgrounds to kind of bring things together. I've done a lot of training, formal training in information security as well, which I'll list here, but I won't go into too much detail around. So how many people here have heard of the Verizon DBIR? Okay, a few hands have come up. Okay, for those of you that didn't raise your hands, Verizon does a study every year. And what they do is they look at various trends at a global scale. They start to look at, what kind of breaches are we seeing? How do we break these things up by industry? And what are the various attack vectors that are resulting in successful breaches? So the report is pretty comprehensive. I've just taken a small snippet here. But we can see that out of the 6 successful breaches that were reported in 2017, we can see web apps takes the cake, and pretty well. It's not even close to its second place winner. And we'll start to look at why that's the case. So why is AppSec so important? Well, one of the issues we run into is applications, and web apps specifically, have a lot of moving parts. There's so much going on there. We have complex authentication schemes. We have various frameworks. We have so much happening, front end, Angular, jQuery, so many different things going on. And with that comes a lot of complexity. As the complexity goes up, trying to secure those things becomes more difficult. So we have to make sure that we're managing vulnerabilities correctly in systems that are becoming increasingly more complex, right? Most companies have an internet-facing app. And as a pen tester, when I come in and I'm given full reign to do whatever I need to do, if I see a web app sitting there, that's the first thing I'm going to go after, because I know that with a certain degree of confidence that I'm going to be able to get in. We've got a lot of the traditional security appliances down. I'm not saying that there's no room for improvement, but the traditional network security, we've done our homework there. Most companies have an IDS, they got a firewall, they got all that fun stuff going on. But it's the web apps that really we're starting to lack. And I know as an offensive security practitioner that I can go in and reliably get myself in there. So why do we see the results that we do in the Verizon DBIR? Well, there's a couple of reasons for that. Many people have gone into the security industry from a traditional networking background. There's nothing wrong with that. But it's kind of the way we've moved into it. And application security then gets left in the dust a little bit. And the field of application security is still very young. Now we have experts in the few experts in this room, like Farshad and a few others, but there are not that many of those people out there. And we need to kind of bring this up a little bit more. So successful management of web application vulnerabilities requires a bit of a shift in thinking. The tools we use are different, the processes we use are different, how we choose to approach vulnerability management really changes. And we can't take a cookie cutter approach using what we do in the regular infrastructure and put it into an AppSec environment and expect it to work. It's not going to work, okay? Developers have a lot of pressure on them to get things out the door. And as much as we don't want to admit this, people who are software shops, your bread and butter is coming from them. The products that they're building is how you're getting paid. So they have a lot of pressure on them to build software correctly. So We don't want to develop that adversarial relationship with them where we're coming from security and saying, hey, you guys need to fix all this stuff. And they're just going to start to hate you, right? We don't want that. So we're going to go through a few slides on just making sure we all understand how software environments work. How many of you are familiar with, a modern software enterprise? How they work, agile, DevOps, all that fun stuff. Yeah. So when we talk about modern software environments, we're talking about things like agile, sprints, product backlogs, and single deployable units of code. There was a time when we would just say, okay, we'll go through this huge architecture phase, we'd build this fantastic application, then a year later we'd have a big launch. We cut the red tape and off you go. Well, now things don't work like that, right? We build things in small increments and we build piece by piece. And the best analogy I can use is Lego. Each piece of Lego can function by itself. But, you can still make something really amazing like a castle with Lego. Each piece should still theoretically be able to function on its own. It just doesn't have much value. Same thing with code, right? You have many developers working on a single feature. You constantly have stuff being merged into production at regular intervals. And in general, an agile team will function like this, right? You have one agile team that has a specific unit of focus. So let's go back to an online banking example because it's easy for us to understand and it's something very familiar to me. So let's say you have this online banking system. Well, it's really complex, right? But you might have one agile team that's focused on a specific area of that. Let's say Interac eTransfer. All they see, hear, and feel is Interac eTransfer. They don't know or care how the rest of the system is working, and they don't need to. That's how agile is supposed to work. So in that team, you have these team of specialists who only do that one thing. And you'll have a business analyst, you'll have a scrum master, you'll have developers, you'll have testers, you'll have a DevOps engineer. And they just focus on that one thing. So what is DevOps? Like, we keep hearing this word. What is it? Well, DevOps is mainly a philosophy, right? It is something that allows us to focus on automation. Traditionally, the way developers used to work, they'd have to do a lot of work to make sure that their software could be tested and could be moved into the various stages. They'd have to do work that was not in their job description. So DevOps kind of focuses on having a streamlined approach to deploying and building code nice and easily. Okay, and it focuses on things like automation, and like we talked about, those little pieces of Lego, continuous integration, continuous delivery, and that's what that means. When the next piece of Lego is finished, I don't have to wait for anything else. I can just attach it, right? And then when the third piece of Lego is finished, I can attach that. So the general pattern that we tend to follow when we're dealing with DevOps is, you'll have a coding phase, you'll have a build, test, release, and deploy phase, and you'll kind of go through these steps one at a time. But DevOps aims to remove this from the developers and the testers. It kind of works in the background to have automatic deployments going on so that testers and developers don't have to worry about that. Developer can focus on writing code. Tester can focus on testing the application, right? They're not trying to build and say, okay, here QA, here, this is how you need to run all your switches. This is the environment I'm going to push it up to for. It's a waste of his time. So we have these automated processes in place to help us. So for those of you not familiar with how version control works, and you might wonder why I'm bringing this up in a talk like this, but everything's going to start to piece together as we get into the second half of the presentation. So let's say we have this online banking application. We want to build this new feature called eTransfer. Well, what we're going to do is the developers that are going to work on that are going to take a snapshot of the existing code and move it off into a copy so that they can do their work on it. And that would be called what we call a branch. And they'll function on that, work on that branch, and until that piece of code is finished, they won't merge it back into the rest. So they have this, almost this siloed copy that they use to work on until the feature is ready. And that's kind of how we want to make sure that we're keeping things separate. So many large enterprises will have various build environments or deployment environments where they house code and house the applications. So many have a development environment where developers work. They'll have a QA environment where testing is done. We have a staging environment, which is what we call pre-production, where customers might come and do a user acceptance test, or it's that last stage before something reaches a production site. And then, of course, you have production. So what's going to happen is in a DevOps type of scheme, now this is just an example. It could be, the timelines could be very different depending on where you guys work and how you operate. But very often what you're going to have is this automatic deployment to a specific environment. You'll have development maybe will get built every day at midnight. So what's going to happen is that master branch gets built every day at midnight. If code is in a branch, it doesn't get affected. But as soon as it gets merged, the very next day at midnight, that code ends up in the QA environment. Similarly, QA, a snapshot of that will be taken every week and pushed into staging. And that staging environment every 2 weeks will end up in production. That's how a DevOps pipeline or a CI/CD pipeline will end up working. Right? So every day when that QA comes to work, he knows that the copy of code that he's going to see is different. So we have a lot of tools at our disposal to help us with DevOps, right? We have automatic CI tools like Bamboo and Jenkins, which does this automated deployment. You can say every day at midnight, take this code and deploy it. We have tools for dependency management like Maven, Ant, and Gradle. Version control, where we do the branching, where we have the master branch and the copies, that's Bitbucket and Git. And then we have issue tracking software, which is like a ticketing system that developers will use, and those are things like Jira. Now there's others, but we're using the most common examples here. So we know that finding security bugs early on is what we want to try and strive for, right? NIST has come up with a metric that says that it takes about 30 times, it costs about 30 times more for you to fix an issue in production than it does in development. And that makes sense if you think about it, okay? Because in a development environment, if a developer sees that he's got a security issue in his code, he can just fix it right then and there. It hasn't wasted anybody else's time. In a QA environment, well, now QA has done his work, developer has done his work, you have to roll back everything. Developer is going to work on that issue again. And then at this point, you have the QA has to do the rework, and then it moves forward. It's still better than in production, but it's now wasting time. In a production environment, the elephant in the room is that, okay, well, you now have got a gaping security hole. So you have reputational financial blowback. You potentially have someone who's able to dump your database and post it on the dark web somewhere. That's a big problem. But the less obvious issue with that is that you could be finding the security issue a year after it was developed. Now that developer's not on the team anymore, he's left the company, and now we have to do a bunch of knowledge transfer to figure out how to fix that issue. It's going to waste a lot of time. So when we're dealing with things like vulnerability management, we have a series of tools that we use to try and help us emulate vulnerabilities, and it's where we hook those in that really help. When you're looking at a CI/CD environment, it's really intelligently trying to figure out, well, where do we hook them in? And in each environment, how do we provide the best feedback? And how do we achieve vulnerability management rather than just vulnerability scanning? So we have static application security testing, dynamic testing tools, interactive testing tools, and of course we have the human element, which is pen testing. We'll go through each one of these and kind of see where they fit in the best. So starting with static application testing. Static application testing focuses on source code, right? It reads the source code of the application and tries to discover vulnerabilities that way, based on the rule engine that it has within it. And because it's reading the actual source code of the application, we call it a white box test, because it can see right inside the application, right? And the way SAST functions is with what we call source and sinks. The source is where data enters into the code from an untrusted source for the very first time. The sink is where that piece of untrusted data will finally execute in a way that it could be used maliciously. So think of you wanting to get into your house and get inside your bed. Well, when you open your front door, that's the source. That's when you first enter your house. And when you get into your bed, get under the covers, that's when you hit the sink. So it's the entry point and the exit point, basically. And the SAST tool, for it to work, needs to be able to follow that data flow for it to understand what's happening. So it might look and say, okay, you've put some code in here, you haven't sanitized it correctly. If this is in the context of a web browser, you're probably looking at a cross-site scripting vulnerability here. So I know everybody here is not a developer. I've made something really simple here so that all of us could understand it. So we have two functions here, very simple, getting data from HTTP request and then executing it against a database. So here, what would be the source? That's one specific line of code. Sorry? Yeah, the request get customer parameter, right? That's where data is coming in from an outside source. It's coming from an HTTP request, right? What's the sink? Yeah, the SQL statement where that code, that untrusted data, is finally getting executed, right? That's where we see the sink. So a SAST tool needs to be able to fall. Now, in a real example, in a big enterprise application, you could have 20 or 30 functions, many classes, frameworks in between that are doing transforms and manipulations on that data. But this is still, at the essence, this is how it functions. So one of the things with SAST is it tends to produce a lot of findings. Just the nature of how it works, it's reading source code. So its results tend to be very verbose. So there is some need to triage and tune and make sure that you're not getting too much, right? So we have to do some stuff to make sure that we're not overwhelming our developers. So as a consultant, I'm often contracted to actually do this stuff incorrectly. And what I mean by that is very often people are trying to fulfill a compliance requirement to say, hey, we're doing source code scanning. So once a year, they'll get somebody like me to come and do a scan and dump of a giant application, come up with what, 10,000 vulnerabilities, and then send a PDF report to people. That's not vulnerability management, right? That's a vulnerability scan. You're just enumerating vulnerabilities, and that's when you start to get that adversarial relationship with developers. Because you sit there, hit a start button, don't do anything, and then give them a report of 10,000 issues. It's not manageable or attainable to be able to fix that. It's too difficult. So a SAST tool speaks to the developer in their language. Most of us are not coders. We don't always understand this stuff. The developer understands it. So you need to bring those results closer to the developer instead of running a scan and then sending it to them. So yes, we need to execute this in the development environment, but how? So most of the time we say that we run SAST scans frequently, daily or weekly. That's a general guideline. But modern CI tools like Bamboo and Jenkins allow you to run these scans at the build or commit level. So we said in our example that a build would take place every day from development to QA, right? During that build, you can have it kick off a SAST scan first before it actually creates the build so that you're able to see just what's changed from yesterday to the next day. Now you're scanning a much smaller piece of code, and it's easier for us to actually manage because we're not seeing 10,000 vulnerabilities, we're seeing 5, right? And you can actually configure these tools so that the build will fail if there are, depending on your risk appetite, let's say you say, okay, if there's a critical or high finding, fail the build. Well, you can't even let in that CI/CD pipeline where you have code moving from development to production. If you fail the build, you can't actually move any further than that. The developer either has to fix it or his manager has to approve it to say, no, this is a false positive, we're okay. So it really helps the developer start to understand how to code securely. And initially, they might hate you and they might say, okay, well, I'm going to start doing this because I don't want my build to fail. But slowly, that'll start to become a habit. And they'll start to code with that in mind. Yeah, initially, it might be because they don't want their build to fail. But then slowly, they'll start developing good security hygiene. So if we look at a Bamboo, this is an example of a build failing because of security issues. Right? So you'll see that the build is saying, okay, we've got some critical, some high, some medium, low findings. I can't build this because there's too many vulnerabilities here. Another example would be a software application like Sonar. This is Sonar Cube, which goes to the code level and tells us, hey, there's an issue and this is the line of code where I'm seeing the vulnerability. Right? So this is really speaking to the developer, not us. So when you hook it into build tools, you're actually letting the findings going back to them versus us doing it later and trying to send it back to them. A lot of these SaaS tools, yeah, there might be a cost associated with this, but a lot of these enterprise SaaS tools also integrate into an IDE, which is where the developers do their work. So in this kind of a situation, instead of failing a build, most times developers will have to compile or run code on their own machine before they commit it to a build server. Well, if they know here that there's going to be a SQL injection issue, they know if they save this and commit this code, the build's going to fail. So it gives them the chance to catch it while they're still coding, fix it before they deploy it up, right? And a lot of these have IntelliSense platforms that can see as you type and can see that you might have created a function that's not sanitized correctly, and it'll highlight it red, right? So SaaS can usually be run on both compiled code and raw source code. And if you want the benefit of this incremental scanning, you usually want to run it on source code, okay? Because it needs to be able to see that difference or that delta between the previous scan. One of the reasons why some people don't use source code is actually a legal requirement, right? Because software is considered intellectual property. It is a copyrighted thing. It's a work of art. So people will say, okay, well, you know, if you're going to upload it to a third-party SaaS platform, it has to be compiled. Those of us who are in offensive security know that reverse engineering is trivial, but that's still enough of a transformation that it becomes okay to do that. So you have a couple of options. You can just move that SaaS platform to an on-premise solution and then have your SaaS server running within your own environment. Then you're not uploading code to a third-party source. Sometimes, I mean, in the past, people have found that there are certain compilers that have been inserting rootkits and backdoors into applications, but that's less common in enterprise applications like Java and ASP. So that would be one of the reasons to use a compiled code versus raw source code. Okay, So the main takeaway from the SAST scanning is to bring it as close to the developer as possible. The longer you wait to perform a SAST scan, the less value it's going to have for you, right? Because you're going to get more findings and they're going to be harder to manage. The next area of tooling we have is dynamic security testing. Okay, so dynamic application security testing, you are essentially scanning a running application. You're seeing what a human would see. You're seeing what an attacker would see. And you know, I don't know if black box is the right word here, but this is what they're generally referred to as, because they don't understand the inner workings. It just sees what the human can see. So the way a DAST scan will work is it'll see a form, it'll try and submit it, and then it'll see, okay, username and password are getting submitted to the server, and it'll start injecting stuff into that username and password parameter and to see if it can try to manipulate how that page is behaving. So we do need to run this kind of a tool on a regular interval, but because DAST is operating on a running and working application, doing it in development might give us some skewed results, right? Because the entirety of the application hasn't been built yet. You still have pieces that are missing. So you're going to get false positives, you're going to get incorrect results. So we want to run this in an environment where we have a working application. Now that could be in your QA environment, that could be in a staging environment, that really depends on you. But looking at the example that we have here, you'd have to scale this to your own environment, but looking at the example we have here, we're running our build daily, right? So we know that every day new code is ending up in that QA environment. So that's a good place to start and say, okay, we're going to run our DAST scan against a QA environment because it's changing every day. The faster we catch it, the less work we have to do. And we don't want to wait a week for it to go into a staging environment, so catch it while it's still in the testing environment. Okay, and the nice thing about these tools is that when they discover an issue, they can automatically post it to a Jira ticket, and then it goes to the individual Agile team's board. And they can look and say, oh, okay, Interact e-transfer, well, that ticket goes straight to them. Nobody else has to worry about it. Because if you have this elaborate triage phase, there's going to be a lot of hand passing back, hot potato back and forth, saying, okay, well, who does this belong to? Who needs to work on it? And by that time, 3-4 weeks have passed, a vulnerability is getting missed. So use these tools the way they're designed to be used. Hook them into your issue tracking system. So here's an example of a DAST scan running. I believe this is Acunetics. And you can see that it's seen an HTTP request, and it's starting to inject some stuff into it and seeing if it can manipulate behaviors, found some findings. That's how a DAST scan will work. The next area of testing we have is interactive application security testing. Now, IAST, or I don't know if I'm pronouncing that correctly, but I say IAST. If the design is to combine the best of both worlds and do a DAST and SAST combined. And there's goods and bads to this. And there's a reason we don't see this as commonly as we do the other two. We'll get to that in a second. But the way interactive application security testing works is it places an agent in the application, monitors behavior, sees what the application is doing. And when it sees something that's questionable or it says, this is interesting, it'll kick off kind of both of a DAST and a SAST operation and try and correlate it to figure out what's going on. So it looks at the running application, but then it also does source code scanning at the same time. Right? So from a diagram standpoint, we have an IAST agent running near the web server. It'll look at requests coming in. It'll monitor it, and it'll say, okay, something's not right here. Let's kick off a little scan. So that's how it'll generally work. So we'd think, okay, it's doing both, so this is the way we should go. But the reality is there are some shortcomings with IAST as well. We'll go through some of the pros first. So interactive testing, we have a lot of libraries and frameworks change the way our code works. Now, we looked at the SAST example, and you see that we have a source and a sink. Now, that was a really trivial example. In a real-life system, you might have things like Spring or Hibernate or these complex systems inside that are in between the source and the sink. And if the SAST tool can't understand that, you'll produce what you call a lost source or a lost sink. It won't understand how the flow works. So because this is operating on a running application looking at behavior, you can sometimes get around some of those issues, right? And because it's correlating a live finding with source code, it might reduce false positives. The issue with IAST is it can also reduce the number of overall findings that you get, and it tends to slow down the application because there's an agent running in the application itself. So again, this is not a general guideline, this is my personal opinion. This tends to work really well when you have smaller and less business or mission critical applications. Right? When you have a big enterprise application, it's usually good to pick tools that are specialized in doing what they need to do. So DAST and SAST separately. So this is a little bit off topic. It's not fully related to security testing and CI/CD, but the reason I'm bringing it up is there tends to be a little bit of a mix-up between what interactive application security testing is and RASP, which is runtime application self-protection. IAST is a scanning tool. It's used to enumerate and find vulnerabilities. RASP, on the other hand, is actually like a protection tool, like an IDS or a WAF. And the way it works is, if you know how a traditional firewall works, a web application firewall is the same. It does basic string matching. Okay, it sees, okay, is this string that's coming in something I'm allowed to pass, yes or no? If it's not, they're very, I don't like to say this, but the firewalls are not the most intelligent devices, right? So a common string that someone would inject for, let's say, cross-site scripting is open script tag, alert1, close script tag. So a WAF will look exactly at that. And if somebody puts alert2 instead, or starts doing some elaborate encoding with hex or Unicode or base64, it may not catch it. So what RASP does is, instead of just looking at trivial matching, it has an instrumentation section inside of it where it actually executes what the user has injected, sees the behavior or the impact that it has on the application, and then makes a decision on whether this is something that it can let through or not. So if somebody injects an alert2 and it sees a pop-up firing in a context which is not expected, it'll say, okay, this is probably not something I'm going to allow, and it stops it from running. So they are different. One is a protection tool. The other one is a scanning tool. Sure. Yeah, if that's a way of looking at it, yeah. The question was, is this kind of going off into a side chain? You use a mechanism to detonate the string that's being injected. Yes, it actually runs it before it makes a decision. So there can be some performance impact with that, because it is having to execute it every time. But just like an IDS, it looks, or an IPS, sorry, more like an IPS, it looks and sees, okay, what impact is this having, and do I need to stop this from taking place? So a lot of application security testing tools. There's a ton more that I haven't listed here. I'm not affiliated with any of these people. This is a completely unbiased list. Definitely HP, or no, I shouldn't call it HP Fortify anymore. It used to be HP Fortify. It's Fortify by Micro Focus now. Definitely a big player, because it does all the dynamic, static, interactive RASP. It has some other stuff in it too. These commercial tools are generally not cheap. I will mention that. If you guys, how many of you guys here have dealt with these before? Some of these vendors. Yeah, they're not generally cheap, right? Right. So you're talking in the multi-thousands for sure. But vulnerabilities cost us a lot too. So we do have to look at sometimes a little bit of a trade-off. Now there's some open source tools as well, and I would say that if you've never used any of these, definitely kick off one of the open source. There's just only a few that I've listed here, but there's tons of them. If you just get a license for Burp Pro, which is $300 a year, it has a fairly elaborate web scanner. Well, that's a DAST scanner. It may not be as robust as as Fortify or Veracode or AppScan, but it's definitely the same thing. And Burp also looks at, when it sees a JavaScript file, it'll read through that file and see if it can detect any vulnerabilities. So it's got a trivial SAST scanner in it too. So definitely play around with some of the open source tools before you start getting into the enterprise ones, just to see how they work. We have to put the obligatory Magic Quadrant up here. You could definitely see that Fortify is one of the key players, and part of the reasons for that is that it does a lot of the different functions that we need, right? A lot of people want a unified vendor. We have things like check marks, which is really good at what it does. It's also very expensive. The IDE integration that you guys saw, that was Checkmark CX Suite, but they only do SAST. And a lot of times that becomes an issue, because a lot of companies say, well, we want to use HP for everything. We want to use Veracode for everything. We don't want to have multiple vendors, right? But some of them are sitting in niche markets. So as much as some of us who are into AI and machine learning might disagree with me, humans are still smarter than computers. And I'm not saying this because I'm a pen tester. I'm saying this because we still need to test our applications for more advanced attacks, and only a human can do that, right? An automated tool is only able to scan certain things. But as somebody who does a lot of pen testing, you can always tell pretty quickly who's doing vulnerability scanning on their applications and who isn't. So if you can go and see, if you see a web form and you're able to inject a tick or 1 = 1, a very trivial SQL injection attempt, if you see that working, you know that there's no scanning going on, because any scanner would have picked that up. So you want to make sure that when you're going through things like pen testing, you're getting the most value out of it. by catching the low-hanging fruit with automated scanners and then letting the pen testers focus on things that are a little bit more complex, right? So despite vulnerability scanning being something that a lot of people do, certain regulatory bodies like PCI still mandate that you get a pen test done usually at least once a year. So keeps me employed. So when we're talking about actually achieving vulnerability management, we kind of know now where each of these different types of tools, where we would hook them into our pipeline, right? We have development, we have QA, and okay, we know where we're going to hook these things in. But when issues are actually reported from these tools, how do we deal with them? So a lot of software shops have service level agreements, right? Just like any other SLA where you say, okay, we're going to maintain a 3-hour uptime, or you're not going to be down for more than 2 hours a day, depending on the industry that you're in. Similarly, when a customer reports a software bug, you have an SLA a commitment that you make to them. And an example could be that, if a bug is reported in this e-transfer application, well, if it's a critical bug, in 2 days, business days, you need to have this problem resolved. If it's a high severity bug, 1 week. If it's a medium, 2 weeks. Just an example, okay? You might be using a framework like ITIL, a known framework. You might be using your own. But it's important that when security issues are coming in, that we don't separate them, right? Because it opens security issues up to negotiation, that they're in a different category than the rest of the security bug. Well, a critical SQL injection finding is not less important than e-transfer not working properly for 5 minutes, right? If one's critical, they all should be critical. Otherwise, things go into a later pile, things don't get dealt with. So when it comes to vulnerability management and actually having this as part of your daily workflow, this is where things start to get challenging, right? You have all these security tickets that are coming in, but nobody's dealing with them. So if you have SLAs as part of your organization's mandates, try and keep them the same. And then when security tickets are not dealt with, it's an SLA breach. It goes into things like key progress indicators. It starts to affect people's bonuses. There's more motivation, more incentive to actually work on things. So how do we achieve true vulnerability management? Well, the first thing you want is high visibility, right? You're going to start your vulnerability management program for the first time. See where you're at. Run the scan. See, okay, well, look, this is how many critical, mediums, and highs we have in this application, and set targets for the next coming year. Say, okay, Q2, I want to be here. Q3, I want to be here. Q4, I want to be here. And set up some accountability, right? Like, see where you're at and see what your targets are. If you're not meeting it, figure out why, right? You want to look at metrics and how you're getting there. The best thing is security awareness, for sure, because, if the business doesn't believe that these things are important, a lot of us, our jobs are not even visible until something's gone wrong, right? If everything's going okay, security doesn't exist. The second something goes wrong, all of a sudden, why didn't you guys do this? So it's important to make sure that the business is educated on how things are working and why these issues are important to fix. So if you look at a full flow, these are based on the timelines or the examples that I gave earlier, but the idea is that you want your SAST or your source code scanning to be running in such a way that if there's low-hanging fruit that's coming from source code scanning, you can't even get it into a proper environment until those issues are dealt with. So things like failing the build, running it very close to the developers, hooking into the IDE. So when you're looking at a CI pipeline, that's what you're looking at. Where does the code start and how does it move until it reaches production? So the better you're doing at actually detecting these issues while they're still in that development environment and not letting them proceed further by doing things like failing build, the less you're going to have to deal with in the next environment. Similarly, in a QA environment, if you're able to manage DAST scans and get the dynamic testing done at that point, by the time things go to staging and go to production, you can, with a certain level of confidence, okay, you know what? I've taken care of most of the source code issues. I've taken care of most of the running application issues. Now we leave it to more widespread testing methodologies like pen testing or other vulnerability management techniques that we have to catch the rest of the stuff. But we've done our part at that point. This little chart here might look easy to do in a real-life organization. It's not quite that simple. It's a lot of work to set up. But it's trying to figure out how early we can catch things and who really needs to see the result from them, right? So in most software environments, what will end up happening is that, let's say a bug ticket comes in. Well, there's a business analyst or some kind of a business representative that is triaging these issues to determine its priority, right? So when we talk about these DAST tools and SAST tools being able to integrate with our issue tracking systems, use those techniques to try and help you manage vulnerabilities better. A ticket will come in, you'll say, okay, we're reporting a problem with e-transfer. What'll happen is the person who's responsible for that, it'll go into a team's, what we call a product backlog, which is a prioritized list of issues that need to be dealt with based on their severity. Security issues are no different, right? So if a critical finding is discovered, it's up to that business analyst to say, okay, you know what? This issue has been discovered. We have 2 days to resolve this. This needs to be moved into our current sprint. Goes into Jira, shows up on the developer's board, and then they have to pick it off and work on it. But again, it is up to the business to make sure that they are prioritizing these findings. That's where the security awareness really comes in. So that when things come in from a security standpoint, they're not treated any differently than they would be if it came from a normal bug that's reported with the functionality of an application. Or a feature, right? It's no different, right? So again, it's that mindset where our job is not, or our role is not really visible until something's going wrong. So educate people, tell them why it's important for these things to have high visibility. So I've actually got some summary. I don't know how I'm doing for time here. I might have, I'm seeing 41 minutes up here, but okay. Well, I've actually gone through most of the stuff that I needed to go through. I went through a bit quicker than I thought I would. So I've actually got a Q&A up here, but I've got some summary going on here. So what I'll do is I'll leave this up so that you guys can ask me questions and you can see a bit of a summary of what we just talked about. So a lot of the, so the question was, how do you deal with false positives from the tools? Well, especially with things like SAST, there's a lot of tuning that has to go on. So one example is, you know, when you load an application into in a Windows or a Linux environment, it'll go to a config or an INI file. So one thing I've seen is some organizations use what we call property files, and it comes from a text file where the application will read from. And those tools will see things like that, and they'll say, okay, well, you got data coming from an untrusted source, but it's not. It's housed inside the organization, right? It's not from the web app. So things like that will come up, and you'll have 300, 400 cross-site scripting vulnerabilities that are not true. So there is a tuning process that needs to happen. A lot of these tools have pretty elaborate macros and rule sets, and you can turn them down. And usually it's better to start with a less stringent rule, catch the most obvious security issues, and then start increasing the level of sensitivity as you know you're not going to get too many false positives, because you actually end up losing credibility. If you have a lot of false positives, again, it starts to train people that, oh, we don't really need to worry about this. Half of them are false positives anyway. So a lot of them have the ability for you to turn it down so that you're able to catch the most obvious issues and then increase the sensitivity with time.
So how do you start doing that? Like, would you do the scans that maybe if you have even like 100 bugs or whatever, vulnerabilities, it wouldn't fail the build, but you would review them first manually, and then kind of once you tweak the tool and gain more kind of confidence in the results, then you'll switch to the more automated way, or?
Yeah, so the question was, how do you actually start this process off? Well, yeah, no, so the initial baseline you would have to do, let's say you had an application that's been live for 5-6 years and you want to start this. Initially, yeah, you will have to do a baseline to see what vulnerabilities currently exist, and then you would start with that incremental scanning. The nice thing is a lot of these enterprise tools, they try not to engage in overlap, so if it's seen a vulnerability already, it won't report it again. So you'll have new vulnerabilities in those new failing builds being reported, but just based on what's changed from yesterday to today. And then you can take the old ones and you'd still have to work on those. Yeah. Yeah.
Is there a tool or a family of tools that provides correlation between the DAST and the IAST and the SAST? So is there a tool that allows you to intercommunicate between these various different types of testing tools so that each know what the other has found and can kind of escalate it from one to the next? Because it's easy to be lost in the minutia with, say, the source code.
Yeah.
Down to these real specific calls. You're saying, well, this is only relevant here, but I can't really get any context of the holistic health of this application. So I can say that this is an issue, but I want to then escalate this to this next tool that steps back a little bit further. So is there any tools that kind of encompass their entire family, providing that holistic view?
I guess that's where the interactive testing comes in, where that can be a benefit. Usually, I think you're right, that's a good point. The idea is that we usually want to catch the more theoretical, I don't like to use the word theoretical because people think it's not an issue, but when you're looking at source code, they are at that point considered theoretical vulnerabilities where you see, okay, this is untrusted data coming in, it's not sanitized. That doesn't mean it's going to turn into SQL injection, but there's a good chance it will. So the idea is that instead of letting it bubble up to that next level, you nip it right then and there, because it is generally good coding practice to make sure that things are sanitized before you go in. But yeah, I think if you wanted them to be correlated, you are looking at an interactive tool. I'm not sure of a tool that would take the two separate ones and correlate them together.
So nobody makes a suite that encompasses all three of those different functionalities.
Yeah, well, if you look here, back here, there is. I mean, Fortify does have all the tools together, right? They have runtime application, they have dynamic, static, interactive. They even have a learning tool that when you click on something and there's a SQL injection issue, it goes and it starts opening up videos on SQL injection to teach the developer how that works, and then it integrates in the IDE. That kind of does the whole shebang. So there is that. Yep. Yeah, so you would, they are smart enough to be able to, did you have the mic? No?
So in regards to criticality,
Yeah.
so in my previous role, we had custom-built similar software where we used to run a nightly scan,
Yeah.
and if it detected something like possibility for the SQL injection, we will have a priority 1 incident coming automatically through incident in ServiceNow.
Yeah.
So no one needs to actually look at it and make the decision whether it's priority 1 or priority 2. It's automatically being done to save time. So does that?
Yeah, no, so what a lot of these tools, they do have a very granular tuning capability. So what you're able to do is you could say, let's say in your organization, in terms of your ServiceNow or your customer level severities, you might have just level 1, 2, and 3. Well, this one will have critical, high, medium, and low. You can assign it so that you can say, well, if it's a critical finding or it's a high finding, give it a severity of 1. If it's you can tune them like that to work. And there are ways to be able to figure out, okay, well, if it's got this Java package, it belongs to this Agile team, so it skips that triage process, goes straight to that Agile team's board, right? So that they know that it's something they have to deal with. Yeah.
So when you're going to assess a company doing a pen test, right?
Yeah.
So you know that you use all these tools, that's source code and dynamic, like everything. So what's your mindset to go there? Because all the low hang fruits is gonna be how do you say, set out with all these tools. So what are you gonna look for, like in the first thing when think about the pen testing?
Well, I can't be 100% whether or not they're using these or not, but generally vulnerability scanners will catch the very simple and easy to execute issues. So if I'm able to see all these alert ones in really, really simple places, generally when I want to execute something that is where there's some scanning going on, I have to be a little bit more creative in getting exploits to work. But if it's really simple to execute, then I make the assumption, I can't be 100%, but I make the assumption that there's no vulnerability scanning going on, because it wouldn't be that easy at that point.
Have the information that that the company is
Not
using those
usually.
tools?
Not usually, yeah.
Okay.
Yeah, usually it's just when
Like
you're seeing, the thing was with a pen test, you're getting less value because the pen tester is spending time reporting findings that a tool should be able to get for you. So you're not really getting the value of hiring a penetration tester at that point. Yeah.
So usually in an organization, who is doing the testing?
Sorry, repeat the question.
Like in an organization, who is actually doing the testing? Who is maintaining those security testing?
This kind of stuff?
Yeah.
It could, you know what? It usually is a combined effort between development and security. And I think that's where we say that there's this paradigm shift, because, and the reason I even went through all this, how does Git work and how do the environments work and how do we deploy stuff, is making this stuff valuable really comes down to which environment you hook it in and how close it gets to the person who needs it. So very often security people will go in their departments and purchase these tools, and they'll do this one-time scan and send PDF reports. Well, things don't get fixed, right? If a SAST scan is functioning on source code, bring it to the developer, let them see, because they're the ones who understand it, right? Nobody else really knows what's going on. So that's why I said AppSec is still very young. You still have security here, you have development here, and there's this really clunky overlap. So it's trying to get both of them to work together.
Yeah, I would.
Just get the mic for a second.
I would think it important to externalize the findings of these tools so that there couldn't kind of be, the results couldn't kind of be hidden away in the whole DevSecOps ecosystem. Like you want, just like we see on the dashboards here, you know, the results of these tools are being made public. No one can hide that inside of their particular units. And as a result, everybody can kind of see the status.
Yep.
So I think this is really great because while it provides this safety net that is obviously going to kind of empower people to move that much more quickly, at the same time it needs to be externalized so that the teams know they can't insulate themselves from potentially what could be a liability for the business down the road.
Exactly, and then when you have things like, you know, SLAs and high visibility dashboards and metrics, you know, a lot of times people when they're getting their bonuses or they're looking at their performance, they're looking at, well, how many tickets got, how many breached their SLA. Well, if security is encompassed in that, then you have a real metric. Okay, the agile team number 35 is really, they're breaching all their tickets. So what's going on? We need to, do they need more people? Is there just not enough awareness? What's going on? Right? So yeah, I totally agree with that.
It's not a question, but I just wanted to add, from my previous role, we actually, the development stage was a bit late. We used to be involved from the project initiation. We used to sit with the developers when they're starting to write things down on a piece of
The
paper.
threat modeling and all
By
that
the
stuff,
time we reached development, that was actually considered as late, and that's why we used to be involved from the start.
That's awesome, yeah.
So,
Requirement stage.
Yeah, that's when you do. And I think one thing I put on here, which is not part of this because it's not related to security testing, but if you look at the general, wow, I'm going really far back. You know, the developer writes code, that starts at the beginning. Before that, you have the architecture phase, and that's where you guys are catching, and that's the best place to get most of the.
Important because at the development stage you'll catch, you can't deal with design flaws, right? Because if there's been an incorrect design, like if the business decided to send the PIN for the banking through SMS, that's not something you're going to be able to change through code. That's something you should have talked about during requirements or architecture to make sure that they're not doing that or using some other channel or doing something else.
You get it right before it even gets into the CI pipeline. Yeah, that's definitely for sure.
You mentioned agile development earlier. How practical is it to add AppSec into like daily scrums or storyboarding or anything like that?
In the scrums, well, you know, when we talk about those tickets getting automatically triaged and pushed into that agile team's board, you know, just like, you know, they would talk about what they're dealing with or what they're working with or impediments that they're going through, that becomes part of their discussion, right? Because now you have this, you know, let's say in the middle of sprint 32, you're 1 week into a 2-week sprint, and this critical SQL injection issue comes in and has a resolution time of 2 days. Well, now the developer is going to say, okay, well, I'm currently working on this thing, which is going to take me 3 days. There's 5 days less than the sprint, but this SQL injection issue needs to be dealt with now. So they're going to start bringing that up in their scrums. I need to stop working on this ticket. Can somebody take this for me so I can work on the SQL injection issue? And now you're starting to get that visibility in Scrum. So it works very well in Agile from my experience.
Respect is adding the evil user stories, right? So during your planning, every time you have a user story, you normally just plan the good user story, right? Like it's like, oh, the user should be able to click on this button and do this. But what you should be doing is doing a quick threat model and then putting the evil user story. And like the bad user will not have authentication, or because there's no authentication, he can also click and do something they shouldn't be doing. So if you're able to put the evil story with the good story in each of the user stories, then you've created a quick threat model and you can plan for the mitigation, but you can also test for it. So when it comes to the testing stage, you've got a test case right there because you've planned the evil story, right?
Yeah.
Awesome.
All right.
Thanks very much. Let's give it a big round of applause for Karim.